So one of the methods of identifying source is a replay attack. The replay attack an attacker identifies a data cell which is being transmitted, and then this data cell is maliciously retransmitted as if it has come from the original source. This way the attacker can get information which could not have been accessed otherwise. So replay attack is implemented by an attacker in the following steps. First of all, on the entry node, the attacker or adversary gets to know about the first cell relay data cell after the initial handshake on the victim circuit and then replicates the cell. Then this duplicated cell traverses through the network and reaches the exit node. A cell recognition error occurring due to duplicate cell at the exit node is identified by the attacker who is already at the malicious exit node. So we'll look at this in detail using a figure. Let's say that we have a case in which Alice is communicating with Bob. Here the destination IP is at Bob's end, whereas the source IP is at Alice's end. Now we'll see how cell recognition error is going to occur. When a data cell is duplicated at OR1, the decryption at OR2 and OR3 fails. This is so because AES encryption is used in the onions layer in counter mode. Due to this duplicate data cell, the counter is disturbed and decryption fails at OR1 and OR2. At each OR, the counter is increased by 1 and a cell is encrypted or decrypted successfully. This count is synchronized, but in this case, this duplicate cell will cause OR2 and OR3 to increase the counter in an unsynchronized way, which will disturb the count of the circuit. This disturbance will be detected at OR2 and OR3, resulting in the failure of decryption. This decryption error is handled by the current TOR implementation in the following way. So OR3 releases the circuit and another circuit is established to provide continuous communication at OR2. Even though a decryption error occurs, but we can see that no change in circuit occurs. This is so because the cell is encrypted in an onion-like structure and the integrity and recognized fields which are used for integrity checking can only be used after all the onion layers have been removed. As at OR2, all the layers haven't been removed, so we cannot use these fields at OR2. However, at OR3 we can use these fields to recognize the duplication error because at OR3 all the layers would have been removed. So now that we know if a cell recognition error occurs, then it will surely show up at the exit node router. We can use this information to confirm that a communication is taking place between Alice and Bob. As we know that at the entry node, information such as the circuit ID, source IP, and timestamp of manipulation is kept, whereas the exit node records information such as the port number, destination IP, circuit ID, and timestamp. By using NTP, Network Time Protocol, we can synchronize the fraudulent entry and exit nodes. If the cell is manipulated at the entry node and a cell recognition error occurs at the exit node, then the attackers are sure that the IDs of the circuit segment tracked at the entry and exit nodes belong to the same circuit, which contains the target TCP data stream. Moreover, as the entry node has knowledge about the source IP of the TCP stream and the exit node knows the destination IP address, the attackers can link the communication between the two IPs using this information, and it will be confirmed that a communication is taking place between Alice and Bob.